recording. Okay, so today let's continue discussing about Q. Okay, and so quick review. So Q, we already know it's first in, first out. Okay, and it has two ends. Okay, front and back, and we also discussed our own implementation. So our own implementation using circular array concept. Okay, and we also discussed the Q, generic Q from Java library. Okay. And for the Q from Java library, we don't need to worry about the circular array that issue. Okay, the Q size full issue. That's just general speaking. Okay, because it's always limited by the machine's memory. Okay. So that's regarding the Q. And today I want to emphasize more about that iterable. Okay, if you recall, when we discussed our own implementation, we said that Q class implement this iterable interface. And this iterable is quite important, okay, because later on when we learn the Java generic collections, we will see this quite often, okay. So basically, the iterable interface then will support the for each loop. Okay, so if you implement some data structure, and that data structure you want it to be able to do the for each loop, then you need to implement this iterable interface. And iterable interface, basically it's a functional interface. So it only has one abstract method. It has only one abstract method. Okay, so you needed to implement. And then let's just a quick review about how we deal with that. Is it? And that abstract method is called iterator. What it returns an iterator. And this iterator is also an interface. Okay, so be careful, it's an interface. But when you implement this iterator method, what you need to return, you need to return an object which implements this iterator interface. Okay, so be careful. You need to return an object. That object implement that iterator interface. Is it? And normally how do we do that is you can create an inner class. Is it? So here is we create an inner class. This inner class implements that iterator. Is it? That's why over here the return type then matches. Is it? And in this case, you cannot write a lambda expression. Is it? Because this iterator interface, it's not a functional interface. So generally what we do, we implement as inner class, is it? You also need to define based on what you are going to do the iteration, is it? In this case, we pick the arrays index as our iterator tool. That's why we initiate to the front index, is it? And regarding this iterator interface, then you do need to implement its 3 abstract method. Has next, so there are 3 abstract methods you needed to implement. The has next method. Okay, the has next method, then you need to check if it's already reached the end of your data structure, is it? And the next method, you need to return the next item. Basically, it's the current item, okay? And then your index, in this case, is going to be advanced to the next, okay? So that's that, you need to implement. And generally, we also implement the remove method, okay? And over here, we didn't implement, okay? So we just throw that exception. Okay, and because of this iterable interface that we already implemented regarding this Q class, is it? That's why if you take a look for the driver part, let's see. Okay, then the driver part for this search to method, is it? Then it just saves us a lot of work to do cloning, is it? Because we don't want to change this Q because it's passed by reference, okay? We don't want to change. So over here, we use the for each loop. Why you can use this for each loop? It's because of that iterable interface. Is it already implemented? That's why, okay. Otherwise you cannot, okay. So always keep this in mind. Okay, so that's regarding this example, we understand just, then if you recall, we also discussed, we use Q, is it, from Java library. Okay, but in Java library, this Q is an interface. It is not a concrete class, but whenever we want to use, we need to use a concrete class. So always use concrete class to create object. Is it? So the one of the concrete class that we can use is called linked list. So this is a concrete class. So we can use it to create our queue. Okay, so that's how we do it. But we just, because this is queue, so we just use the queue parts. Okay, so like in this case, this Q1, is it the type? Type is Q. Because type is Q, so it supports first in, first out. So if you want to do any application regarding in order first in, first out, then you can use Q, is it? But when you do new, you need to do linked list. You cannot do new Q, be careful, okay? You need to do new linked list, okay? Because linked list implements Q interface, so it supports first in, first out, okay? And you want to add it back, it's called add. Okay, you want to retrieve the front item, it's called pick. Okay. And then let's see. It also supports for each loop. Okay, because in the library, that linked list also implement the iterable interface. So for each loop is also supported. Okay, and previously we also mentioned for Q, it also has a method called for each. You can also use this. Okay, and whenever you use this, you can plug in lambda expression, etc. So this basically is just item in the queue. Is it in the queue one by one? Okay, and then you can do something on it. Okay, so you can also call this for each method. And this for each method versus this for each loop, its advantage is you can do chained, we can do streamline, we can do streaming processing. Okay, stream processing. Later on, we will learn. Okay. And for Q also has a method called iterator, and then it returns an iterator. Okay, it returns the iterator, and that because it returns the iterator, so you can also do has next and the next. Okay, then in this case, with and you may ask, why do we need this? We already have the for each loop, is it for each method? Because sometimes you may need to do remove or add when you iterate. And if you want to remove or add when you do iterator, you cannot use for each. You cannot, okay, because for each only applies to fixed size. The size cannot change. If you want to do a dynamic way, it's adding and removing while you do iterating, then you need using iterator. So it will, so even though you do add or remove within this loop, it will keep doing. It won't be messed up. Otherwise, for the other case, it will mess up. Okay, so that's the point. So then because of this benefit, you can use this hasNet and next to do something. Okay, so that's regarding this iterator. Okay, there is another method like this iterator. Is it method return your iterator? Then you can also kind of advance the iterator. Is it to somewhere? To somewhere. Then you can do something like for each remaining, you can also apply this method. Then it will start at where you specify. Is it? Maybe sometimes you don't want to start at the beginning to do the loop. You want to start 1/3 or 1/4 someplace to do the loop. Is it? Then you can use this method for each remaining. Okay, so that's the benefit of this method. Okay, then let's take a look. This search method. Is it for this search method? And we don't want to change this queue. Is it? So for queue with the library one, if you want to do a deep copy, you can call this add all. So basically this kind of deep copy. Okay, deep copy. Then whatever you work on that, it won't impact the original. Okay, so that's the idea here. Okay, So that's regarding the Q, okay, library, from library. And then next, let's take a look at the other example. So in this example, we use both stack and queue, okay? And this time, the queue is not on primitive data type. So it's on a concrete class. Is there on some reference? So this book we also implement clonable and comparable, okay? So let's see. So for this book, it's quite straightforward, just has two instance variable ID, is it, and a name. And we do the clone. And in this case, you just call clone. This is a deep copy. Okay, why? Because the instance variables, they are either primitive or it's immutable. So that's okay if you just do this, okay? So that's a deep copy, okay? And we also implement the compare to, okay? This is from the comparable interface. This is also quite important interface because later on when we learn container, the collections, we will see this is also very useful, okay? So anyway, let's get back, is it? So this time we create a queue. This queue is regarding a book. Is it? So you just plug in a concrete class type to the angle brackets. Okay, let's call new linked list. Then we just keep adding new book. Keep adding new book. Is it? And it's going to be added at the back. Okay, so it's going to look like B, 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 B first, following by A. Is it then following by C, then A, B, C, 1, then A, B, 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 is it? So that's regarding this queue. Okay, so this is that book queue. Okay, you keep add at the back. And then here we call remove. When you do remove, you remove the front. So it's out of the queue. And here, there is another method called poll. Poll also remove from front. Okay, so both remove from front. Remove at front. And both remove at front. So what's the difference between these two? Okay, there is just a subtle difference. For this remove method, it throws exception if Q is empty. Throws exception. Basically, remove is our DQ operation. Okay. And for poll, it doesn't. It just return no. So that's the difference between these two. Okay. So it depends on what scenario you want to use. If you want to take care of exception, you use remove. If you just want to determine if it's no, then you use poll. Okay. Okay, so that's regarding this too. And then the same thing regarding you retrieve from the front. So retrieve front item. Okay, we also have these two sets. So the difference between these two sets is, so the element is throw exception. No such element exception. While pick just return no if the queue is empty. Okay, so that's the difference between these two. Okay, and then for queue, it also has a search method called contains. Okay, so this is also pretty straightforward. And we can also do for each loop here. Is it? So this is for each loop. The loop variable type is a book. Okay, so this is pretty straightforward. Okay, it's just regarding book. And what next? We also learned the stack, is it? So we can also create a stack. So sorry. Okay, so we can also create a stack, as I create a stack. So this is a stack of book, okay, stack of book. So what over here then is we just call the push, is it? So the first book added going to be at the back. This is second, then third, then fourth, something like this. Is it keep adding, is it? And you can also output the stack. So basically, the stack class in the library also has a toString method, so we can directly do it. Stack also has a method called search. Okay, so you can also call search to try to find some item. Okay. And then next, pretty straightforward. And for stack, if you want to remove some item, you just call pop. Okay. And it also has a function called pick. Pick is at retrieve the top item. Okay, so pretty straightforward. And then what next? If you take a look for stack, stack also has this method for each method. Okay, so you can also use for each method to do the loop. Then it's pretty straightforward, just an item from the stack. Okay. Okay, so this is regarding how we use the libraries. Okay, so it's much more flexible because we don't need to worry about the type of the stack or queue. We just go ahead, directly use it, and then parameterize it. Okay. So that's the basic idea about the stack and the queue. Okay. So what next one I'm trying to discuss is about the library. Okay, from the Java library. Is it? So first, let's take a look at the queue. Is it? So clearly you can see Q is an interface, is it? So we can plug in whatever type, is it? But must be reference type. Must be reference type, okay, when we use it. And then let's see. So you can see it says this is an interface, it's a super interface, it's iterable. Okay, so basically in the library, if we draw it, looks like this, then Q. Okay, that's a super interface. Okay, and so implementing class, is it? If you take a look here, that's the implementing. So linked list implements this Q interface. If you take a look, you cannot find array list. Is it? So array list didn't implement. So basically, the class linked list, when you define it, is it? It implements the queue. Okay, it implements the queue. Okay, implements the queue interface, is it? Because it implements the queue interface, so within linked list, it needs to implement whatever the abstract method in queue. Okay, so next let's see the queue. So what over here is that basically for interface queue, that so it's summary of the queue method. It has add, and it can, you can also call offer. Okay, so the difference between these two sets, it's the same as remove pull and element versus pick. So this group throw exception, and this group return special value like null value. Okay, so that's a major difference, okay, between these two. So it depends on the scenario that you want to use, okay. Okay, And then over here, is it? So over here, it's, so this add method, element method, all of this method, they are abstract method. Okay, so add is add at the back, offer remove from the front. So that's why then when you implement, you need to follow the rule. Okay, so basically, if we take a look, this is, they are all abstract method. So that's why that linked list, then later on, you need to implement it. So next, let's take a look at the linked list. Is it? And if you take a look, linked list class. So it's a concrete class. Okay, concrete class. And it implements interface queue. Is it? It also implements other interface like iterable interface. Okay, some other interface later on we will learn. Okay. So it implements multiple interface, is it? And for this linked list, if you recall, then it should have, if you recall, the add method. And here, that should be concrete method, is it? And we can see if it is. It is concrete method. So it's implemented. Okay, it's implemented. We have the add, we also have this element, is it? And we also have pick, is it? And pull and remove, is it? So this linked list, you can see it does provide all of the implementation of the method that's defined in interface queue. That's why we can use this linked list as our queue, okay, to let it work for first in, first out for FIFO's data structure. Okay. Okay, so this is regarding linked list. Then next, let's take a look. This iterator, as we discussed. So iterator is an interface. Okay, interface. And then let's see this interface. This interface, so basically what it supports, it's just to over some collection, is it? Over some collection. And when basically it allows you to do some enumeration work. Okay, some enumeration is just one by one work, is it? You take one by one. And but it also allows us to remove. Okay, remove, not just visit. Okay. So that's the benefit parts. Okay, and then let's see. If you take a look, then you may ask, when we implement that iterator, when we define a class, concrete class that implement iterator interface, we just implement has next, and remove. We didn't implement this. Is it for each remaining? Okay, that's because these three are abstract methods. Okay, and this is, oh, I'm sorry, the remove is also default method. If you take a look, the for each remaining, is it? Both of these two are default method. Okay, so default method, then it's implemented, is it? You can also override it. Okay, so let's see. Here, we have abstract, these two are abstract, is it? The default, these two are the default method. Okay, default method. Okay, and so when we implement an interface, default method, it's not mandatory that we need to implement it, okay, because it's supposed already implemented, but you can override it, okay. Okay, the next is about that iterable interface, okay. So for this iterable interface, let's see, iterable interface, you can see implementing class, a lot of class implement it. Is it that iterable? And if you take a look, the linked list, is it that we use for a queue? It's also implement the iterable interface. That's why we can do the for each loop. Is it stack also implement this? So you can also use it for stack, okay. Okay, then for this iterable interface, is it? So let's see, it's abstract method. If you take a look, it has this is the only method, is it? So that's why we say iterable interface is a functional interface. Versus iterator, it's not, okay, because it has two, next and has next. It has both of them. This is functional because that's the only method it has. Okay, and then let's see. This default, it also has default method for each and some other one. That's why we can also use for each. Okay, so this is regarding regarding iterable. Then let's also take a look at the stack class. Stack class previously we learned is that it's implemented interface, it's iterable interface, that it's implemented, okay. And for stack, okay, for stack it says you can also initiate with array DAC, okay, later on we will learn, okay. But anyway, because the class itself, okay, the class itself is a concrete one. That's what we learned. So we can directly use it, okay. So let's see the method. It has a concrete method. So pick, pop, push, search. That's why we can use all of that, okay. And it's instance method. Those are instance method. Okay, so that's regarding stack from the library, okay. So we kind of learned queue from both our own implementation and the library one, okay. And when we discuss our own implementation, we just discuss the array case, okay. And in the real world, when you use like a stack, queue, those data structures, normally we don't use array because the data size is quite large, is it? Then if we use array, they are not very efficient. So that's why if you see in the library one, the queue, we just use a linked list. So it's linked way implementation, is it? And anyway, here we are not going to discuss queue implemented in linked way, because later on we are going to learn linked list, how we do the linked way implementation, okay? Then you will fully understand, okay? Okay, so that's all the